applications of trig, and I kind of stole this from your book since you don't have a book, right? So that you could read it. But it talks about like what are applications of trigonometry. In the first two sections, which is today and next week, we're going to talk about how we can solve oblique triangles. Do you know what an oblique triangle is? Yes. Oh, like you're remembering the law of sines, right? That's what you're about to tell me?
No. Oh. Well, I was going to tell you, I was going to ask you to print off our thing.
Your book?
Yeah.
Well, I printed off a little bit of your book, yes.
Okay, I was making sure.
An obese?
Yeah, obese.
I gotta write that one down.
It's going on the list of things.
Like, that's how I know it. It's like, cute is like baby, and little things are cute. And like, right, like, you're probably right if you just guess 90 degrees. And then obliques is like obese people, where they're bigger than everyone else.
Yes, this.
Oh, obtuse is what you mean instead of obese.
Yeah.
But obtuse is just an angle, a triangle has an angle bigger than 90. Oblique can be a triangle that's acute, but what's missing from an oblique triangle? Like, it's not a right triangle. What's a right triangle?
A triangle with no right angles.
Oh, it's a triangle with no right angles. It's not going to
Well, it could be.
It could be obtuse, but it could also be acute. So, up until now, everything we've done with trig has been centered around right angles. If it didn't have a right angle, we couldn't do it. So Katoa only works with right triangles. But now, using the law of sines and the law of cosines, we can deal with non-right angles, which means things in life that don't make perfect right angles, we can now still solve for the missing sides and angles. And then we're going to talk about vectors, which is kind of a new topic for everyone. And then we're going to talk about the trigonometric form of complex numbers, which is kind of like polar form. Remember that from pre-cal? Kind of just a big mess of this chapter. But after this chapter, we just have conic sections, and that's it. And those are the only two things we have left to do this whole semester, which seems like not that much stuff, right? A lot of time left to do all this stuff, which is good. Oh, wait, what am I doing? Okay, here we go. So I drew this lovely oblique triangle. I drew an acute oblique triangle, but it could be obtuse. And notice I label the sides A, B, and C, and I label the sides across lowercase. I do want to point out that your book labels those angles, like they label angle A as alpha, which makes sense, and they label angle B as beta, which makes sense, which means the one that you have no clue what letter that is in the Greek letters, that's just what they call C, which just kind of looks like a Y, or like a fancy Y like that. That's angle C, where I use a capital C, they just use the Greek letters. So you can't, in your homework, they use those letters, so that way I just want you to know what it means, right? I'm trying to think what that letter is. I never know that letter. Fancy Y, gamma. That gamma is C in the Greek letters. So that makes sense, right? It goes alpha, beta, gamma. So that's why they use gamma. Makes perfect sense. When you're using the law of sines, they talk about this stuff, which maybe doesn't seem that important, but you can only use the law of sines if the given triangle gives you two angles on any sides. If you remember that, that's like angle, side. Remember these things from geometry class? Two sides and an opposite angle would be angle, side, side. Oh, that's that word. Side, angle. You're supposed to write it like that, so you don't write bad words on the board. Just saying. Also, if they give you all three sides, then you can solve it. Or if they give you two sides and their included angle, which is angle, side, angle. All of these work. We're going to talk about the side angle in a minute. If you remember from geometry class, that was not a way to prove that two triangles were congruent, and that's going to lead us to a problem with law of sines. We can still do it, but it just causes more problems and more work. Yes, dear?
Why do ASA has two sides?
Isn't two sides side?
Yeah. So why do you have ASA?
Oh, look, I was doing this. Two sides in their included angle. It should be side, angle, side, right? So I think side, angle, side. Law of sines is basically just a ratio of the sides and the angles, and it doesn't matter which two you use. It's whatever's given there. So I wrote this out for you. But basically, you can take any side A over the sine of the angle, side B over the sine of the angle, or side C over the sine of that angle. You don't need all three of them, but they're just all equivalent. So you only pick the ones they give you. It's also true to flip it around, which means the sine of angle C over side C is equal to the sine of angle B over side B, which is equal to the sine of A over side A. Why would you want to flip it around? I don't know. I always say, like, whatever I'm solving for, put on top. It doesn't matter. Like, those are the same thing when you want to flip them around. And so then I just kind of wrote it out in words for you, just so that you could see, like, what we're saying, that the ratio of the side over the sine of its angle is just equal to the other ones. And so, I think I made you fill the blank, right? In any triangle, so not just a right triangle, in any triangle, the ratio of an angle to the side opposite that angle is equal to the ratio of the sine of another angle to the side opposite that angle. And basically today we just want to look at some problems. It's not that bad to do. And then we talk about this special case of angle side side and what that means for us. It's actually way less work than some of the other stuff we've been doing. But you aren't going to get super pretty answers, which means calculator is definitely going to be required. Also, it says in your book to round to whatever decimal they give you. So if they give it to you in 1 decimal, then your answer should be rounded to 1 decimal. If they gave you rounded to 2 decimals, then your answer should be rounded to 2 decimals. I drew a lovely triangle here. It doesn't matter how you draw the triangle. It doesn't have to look right as long as you label it correctly. So notice on this one, I'm going to call this A because that's my biggest angle. And I'm going to call this B, and I'm going to call this C. And they tell me that little a, that's the side across from A, is 21.6. They tell me that angle A is 102.4. And they tell me that angle C is 16.7 degrees. So notice what they've given us is angle, angle, side. You have to solve for what's missing. And we've done this before, only we did it with right triangles. Every time they're going to give you 3 things, and there's going to be 3 things missing. In this one, they give us 2 angles, which means can we solve for the third angle pretty easily? Because we know the angles in any triangle always add up to 180, which means we don't even have to use trig to find angle B. And again, I call it capital B. In your book, they use beta. I don't care which one you use as long as you just understand what the book's saying. But I'm going to say that angle B is just going to be 180 minus 102.4 minus 16.7. And I got 60.9 degrees. You agree with that? 60.9 degrees. Does anybody need a calculator? So we can practice. So we're doing this correctly. So then we're missing 2 sides, right? We're missing side C and we're missing side B. We cannot do Pythagorean theorem. We cannot do SOHCAHTOA. Those only apply to right angles, so this is where we have to use the law of sines. And this is where I'm going to use what they gave me. They gave me side A and angle A. So can I say that 21.6 over the sine of that angle, which is 102.4, which one do you want to solve for first, B or C? I'm solving for B, which means what do I have to put on the bottom? The sine of angle B, which is 60.9 degrees. Notice I put the sides on top because that's what I'm solving for. I used to always say you should cross multiply here because it's a proportion. And then I had a foreign exchange student that said that was silly because when you cross multiply, you take this times this equals this times this, and then you end up dividing this back over, right? Which works. And they said, why would you do that? When all you got to do to solve this is multiply both sides by the sine of 60.9. Right? Isn't that going to solve for B? If you want to cross multiply, you're going to get the same answer. I just had never thought about that I was creating more work for myself. So I just like to share that with you. Make sure you're in degree mode, right? You only have your graphing calculator? Oh yeah, this is going to be a disaster. Make sure you close your parentheses after you do your signs. I got 19.3. Anybody else get that or on their way to get that? You got 21.6? Three, two, four, yeah. But since they only rounded to one decimal, we're only going to round to one decimal. Anybody else not get this?
Okay, now I got it.
And then, unlike the right triangles, like you always have the choice of going back to Pythagorean theorem. You don't have the choice Pythagorean theorem on this. Like, you just have to do it again, but it's the same thing to solve for side C, except for we're going to change this side, right? So I can do another one, 21.6 divided by sine of 102.4 is equal to side C over to sine of angle C, which is 16.7. And I'm okay if you don't even, like, if you just do it on your calculator and tell me what that equals. You don't have to show that you're multiplying that over, as long as you know what you're doing. So now we're going to take sine of 16.7, 21.6, divided by sine of 102.4, and I got 6.4. Again, there's not really a great way to check your answer, but you can at least see if your answer is reasonable. The biggest angle has to be across from the biggest side. The smallest angle has to be across from the smallest side, and that is true in this. So that helps you feel more confident in your answer, I think. But each problem, it's like three in one problem. I know, this is side angles, right?
That means you only give us like
4, 7. Obvious.
Yeah, just
I don't know if I did my math wrong, but I got a different answer.
I remember this.
and like I'm just
We did exact same.
really sure what it is. So I'll probably understand it right now.
Wait, then you multiply it by sine of 26.
Wait.
You do by sine of 16.7.
Oh, I see what it is.
Okay, so this is really not that bad of math, and then we get to that lovely side-side angle. The reason that side-side angle was a no-no in geometry, not just because it's spelled a bad word, but because it can lead to two different triangles, or it could lead to no triangle, or it could lead to one triangle. So that's why we couldn't use it in geometry. We can still use it here, but three things can happen. We can get that there's no triangle formed, like when you graph those two sides and the angle, like they don't meet up to make the third triangle. We can get one triangle that sometimes turns out to be a right triangle, and sometimes it turns out to be an oblique triangle, or sometimes you get two different triangles. You get one acute and one obtuse triangle. So we got to figure out how to do those. So first of all, I printed off this page from your book just so you can see the four cases, really, right there. Your homework's on the other side of this, don't go away. But instead of me trying to draw these up there, they give you those four cases. And so A is the example of no triangle, right? Like when they graph the two sides and the angle across from it, like it just doesn't make the third side. B and D, those are the example of one triangle. Sometimes you actually get a right triangle. Most of the time you get D, which is an oblique triangle. C is the crazy case. Sometimes you can make two different triangles. You can make an acute and an obtuse triangle. You're never going to actually have to draw these out, but I just wanted to show you the geometry of it. We can use algebra and trig to figure out how many triangles there are going to be by just solving it. So here's what you have to recognize first. Is it side-side angle? If it's side-side angle, you have to know to check for two answers. And it's not going to tell you. Like, you have to look at what's given to you. So let's look at this next problem. And this is why I always draw the picture. And my go-to picture is always an acute angle, like an acute triangle, even if it's obtuse. I tend to draw this, but it doesn't matter. However you want to draw it. A, B, C. So they give me A is 58 degrees. Side A is 11.4. Side B is 12.8. Do you see that that is angle side side? So you have to recognize angle side side. I could have more than one answer, all right? So side side angle. You got to recognize that. We're going to start out the same way we always start out. If it's no triangle, we're going to start to solve this, and then we're going to get an undefined problem, and we'll have that. If we get one triangle, you have to check for the second triangle, all right? So the big thing on your test is you got to recognize this. But step one, let's start. We don't know, what do we have to start with on this? What's the only thing we could solve for right now? Yeah, we can't do anything with C, because when you set up 12 signs, you have to either know the side or the angle. We don't know angle C or side C, but we do know side B. We don't know angle B. So I'm going to say the sine of A, which is 58 degrees, over 11.4 equals the sine of B over 12.8. You notice how now that I'm looking for the angle, I flipped the law of sines around and now I put the sines on top? You don't have to do that, but it just makes solving so much easier, the fact that you can just flip them. So whatever I'm looking for, that's what I put on top. Because now what would I have to do to get sine of B by itself? You know, all I got to do now is multiply by 12.8, whereas otherwise you'd have to like flip stuff over. So that's going to get sine of B by itself. We'll have more work to do. But let's type this in our calculator and see what we get. Probably something not very pretty. Well, that was weird. 12.8 times sine of 58 divided by 11.4. I get, and I'm going to write a lot of decimals here, okay, because we're not done with this problem yet. I'm actually just going to write them all down. 952194354. That's what gave you an extra decimal. That's what sine of B equals. How can I figure out what B equals? Yeah, I'm going to do the inverse of that. And you might even, some calculators let you do inverse, and you can go up and pull that same number down so you don't have to type it all in. Or if you want to do inverse sine of this whole thing, you could do that too and not write all those decimals down, but I just write the decimals down. 0.952194 354. Inverse sine, the sine negative 1, I get 72.2 degrees. Did you get 72.2? So, that works. That gave me a triangle. So here's how do you check for the second triangle. Do you agree that when we do inverse sine, there's always two answers, right? Right? So this is where you have to use your reference triangles. If there's an angle up here that's 72.2 degrees for sine, what other quadrant is sine positive in? So we would want to take B, so I'm going to put or B could also equal, how could I figure out this angle? Measuring from here over to there. Yeah, subtract 180 minus that reference angle. So 180, oh my goodness, minus 72.2. And here's what's super great. Law of sines, it's always going to be sine, right? It's always going to be sine, and they're always going to be positive angles, which means to find your second angle, you're always going to be taking 180 minus that. And I get 107.8 degrees. So how do you know if there's two triangles? if you can make a triangle, if you can find a third angle, then it works. So here's the question. When I take 107.8 and I add it to 58, if it's bigger than 180 already, do you agree there can't be a triangle? Because if it's bigger than 180 when you have two angles, it can't have a negative angle. But when I add 107.8 plus 58, I got 165.8, which means, could we find what angle C is for that one? It's going to be really small, right? Like 14.2 degrees would be that third angle. That's a tiny angle, but it works. If you got a negative angle here, that's where you'd only have one triangle. So what's super great about this? You have to solve for the missing parts for both triangles. So now we've gone from solving for 3 things to solving for 6 things. Okay, sorry. You don't seem as excited as me. So here's my other angle C. Over here, if I take 180 minus 72.2 minus 58, I got 49.8 degrees. And I like to just put a big or, like I really just say or and. You have your 2 separate triangles that you're making. And what's the other part we need to solve for still? Side C, like we found this. We found that there's an acute and an obtuse angle C. We got to find the sides for both of them, which means we're just going to set up law of sines. You can use whatever you want. I always use what they give me, right? I always am going to use the A and the A if they give me whatever angle inside they give me. I use that so that I'm using the given information. But you have to use your angle C's that they give you. So 2 different problems. Could I say C over sine of 49.8 degrees equals 11.4 over sine of 58 degrees? And over here, I'm going to do the same thing, only I'm going to use sine of 14.2 degrees equals 11.4 over sine of 58 degrees. And again, I don't show all my work. I show the setup, and then I type it in my calculator. But that way, if you show me the setup, I'll know that you had it set up right, and maybe you just typed something wrong in your calculator. So it is a bit more work, but it's not awful. The worst part is just remembering to check for it, I think. So let's see. Typing something in wrong in your calculator like I just did. Or if you have one of those calculators where you can go up and retype, all you got to do on this one is change the sign, this angle. Like you could just go up and change the 49.8 to 14.2, and you can even save yourself some work on that. Sine of 14.2. I got, well, that can't be right. 3.3? Oh, that makes sense. Sorry. I was thinking the side across from 107, but no. This is smaller than this, so it makes sense that this is smaller than this, right? My favorite is when there's no triangle, because that means I don't have to do all this work, right? My least favorite is when there's 2 triangles, because you have to solve for both of them. So that whole idea of reference angles comes back to haunt us, right? Let's do the next one. Guess what? I bet it's angle side side. Side angle. When I taught geometry, I always told my students to check their test before they turned it in, and if they wrote a bad word on it, then that's the wrong answer. But every time, someone still did it. Again, my triangles tend to all look sort of equilateral, but it's just to let me visualize it. I don't actually have to try to draw an 85-degree angle. We use 25 side angle. And when it's side angle, when they only give you one angle, there's only one place to start. You have to figure out what's the other thing you could solve for right away on this one. You got to solve for angle B. So Setting that up, I would get sine of 85 over 15. Last hour I was telling my second hour class how many preps I was going to have tomorrow, and Zane Yon said, "Are you stoked?" But I thought he said, "Are you stoned?" And I just kind of stared at him for a second. And he's like, "I would be excited." And I go, "Oh, okay, I thought you just asked me if I was stoned." And I was going to say I didn't think that was brilliant. I got 1.660324497.
I thought you said it didn't matter one way they were going.
What do you mean?
And I wrote it,
So what did you write?
well, the first time that I wrote that, so it was not right, but I wrote it like upside down the other way. I thought you said it didn't matter one way.
It doesn't. You just have more algebra to do it, right? Like if you write it like this, you can't. You have to do more work. So this is why I don't write it like this. Right? You have to get this sign of b out of the bottom, so you can't just like divide by 25. You could. This is where I would cross multiply. So you could say 25 times 15 equals sine of 85 times sine of b, and then you could take 25 times 15 divided by sine of 85, and that will equal the same thing that I got.
No, but that's exactly what I did. Except I got like 300 and something. That's why I was like, oh, I'll just try to do it. Because I didn't write it like this. I mean, I wrote like 15 over sine of 85 equals 25 over sine of b, and I got like 300 and something.
Oh, look what I just did. You can't do this.
I didn't do that.
If we did this, then it would be
Yeah.
this, right?
Yeah.
So, that's much better. Which means you would get 25 times sine of 85 equals 15 times sine of b. So you would get 25 times sine of 85 over 15.
Yeah, I didn't do it.
Right? So if it's on the bottom, you have to cross multiply to do the algebra. That's why I always, whatever I'm solving for, I put on the top so that I don't have to do all that work. You get the same answer, it's just more work to do. It easily mix up. Jake said, this is out of our domain, because sine can't be bigger than 1. But the great thing is, if you forget that, if you do inverse sine on your calculator of 1.66, it will say domain error. It'll say undefined, because you can't take the sine of something bigger than 1, which means, is there an angle that meets this requirement? There's not. So that means that there is no triangle formed. Given those lengths of sides and that angle, it does not make a triangle. And so you get to stop. There's no triangle. One more, at least. Do I have 2 more on here or 1 more? Just 1 more, right?
Yeah.
So we did 2 triangles. We did no triangle. What do you got this one? Let's see what happens to how do you get just 1 triangle. Oh man, look at this fancy triangle I drew. A, B, C, 22. Oh, I don't think this matches very well. 12, 42. Look how terrible my triangle's labeled. 12 looks much bigger than 22, but that's okay. As long as you label the sides and angles correctly, it doesn't matter if it looks terrible. Again, it's angle side side. Works out great when there's only 1 triangle. If you forget to check for the second one, you get lucky because there is no second one. But we have to start with solving for b again, right? That's our only choice. So I can say sine of b over 12 equals sine of 42 degrees over 22. So then I take the inverse of that. And I got got 21.4 degrees. Did you get 21.4 degrees? So because it's angle side, you should always check for the other option. And so the other option is always going to be in quadrant 2 for sine, which means your other option is always going to be 180 minus that. And if I take 180 minus that, I get the other possible angle is 158.6. Here's how you can have only one triangle. If you take 158.6 and you add it to angle A, do you agree that already exceeds the angles allowed? Like you can only add up to 180 degrees. So you can't have 158 plus 42 already being bigger than the angles in a triangle can be. So this doesn't work. What I want to see is I want to see that you tried that, right? I want to see the work so I know that you knew that there was a possibility of a second triangle. But because that's bigger than 180, so if you want to write like A plus B is bigger than 180 degrees, that's why you can't do it. You don't have to write that on your homework. But that's the reason we have to cross it out, because 158 plus 42 is bigger than a triangle can be. Which means you only have one triangle to solve for. So you just need to solve for angle C and side C now, right? Mm-hmm. Yes. So I gotta solve for angle C first. Do you agree with that? Because I can just subtract from 180. 180 minus 21.4 minus 42 gives me 116.6. And then I can say C over sine of 116.6 equals 22 over sine of 42. And make sure, since you have multiple answers on these, make sure you label them, right? Like C or A or whatever, so that you don't just have random numbers on your paper not identified. I got 29.4. Did you get that? Which makes sense. That should be the biggest side because 116.6 is the biggest angle. So not all of your homework is side-side angle, but there's definitely some of them that are side-side angle. So that's where you need to look at those. But it's just practicing those. What's left that we're not going to do tomorrow is that we'll do on Thursday is story problems. So then taking and solving story problems with oblique angles and being able to use false signs. That's really all that's left in this section. So you just have to do 3 through 15 multiples of 3 today. Look for those side-side angle cases. I didn't make a copy of the back of the book because the copier was ridiculous this morning. No one was hogging it. But so I guess you can't take your answers. But just try them, and we'll talk about them on Thursday. Those that are going to be here tomorrow, we can talk about them tomorrow, and you can work on them. Quiz after 8-2, so that probably means that we'll have a quiz next week over 8-1 and 8-2 before spring break. 8-2 is just lost cosine, so I would